students, so you have made it to the final video in the cycling of matter for this week, and we will be discussing the phosphorus and the water cycle. Before we start with the phosphorus cycle, let's take a look back at the carbon and nitrogen cycles and see some commonalities they had. So with the carbon and the nitrogen cycle, we kind of saw this rapid change in matter from solid to gas. There really wasn't a liquid phase for these particular cycles. Okay, and additionally, we saw the rapid recharging of elements in the earth. So this kind of rapid movement from inorganic to organic. Now, with the phosphorus cycle, we might see some differences. So, with the phosphorus cycle, the main reservoir is actually in these rocky mountains or phosphorus-rich rocks. So some places on Earth actually have quite a bit of phosphorus in their mountain ranges. So Morocco and northwestern Africa has a lot of phosphorus-rich deposits. Some places in the United States, I think in Arizona, Colorado, they have some pretty rich phosphorus deposits, and basically it's mainly coming from these rocks. So you first have wind and rain erosion to make these rocks into smaller, finer silt. Typically, if we're mining for phosphorus, we're going to do this ourselves through industrial processes, okay? And usually also through dynamite explosion, so you can reduce that rock into finer rubble. Then rivers and streams are actually going to carry all of that fine silt into different water bodies. So this is naturally occurring, not necessarily what we're doing. Then we would take those rocks, if it was artificial, and we would create fertilizer, okay? But basically, by taking those phosphates, that's going to leak out into the different producers and plants, okay? So they absorb the phosphorus from the soil. Consumers are going to eat that phosphorus, and then decomposers are going to break down their waste to put it into the soil, so it just continues to cycle naturally through the different organic layers. So you can see that it pretty much stays organic in this little part. Okay? Now, if we look at the long-term cycling of phosphorus, it's eroded from the wind and the rain. It gets moved or transported through the water, and then it settles down at the bottom of a water body and becomes sediment. Over millions of years, that sediment eventually becomes rock layers and mountains, and as our tectonic plates and the general processes of geological uplift work, that new rock is going to also emerge up as a new mountain range, and this mountain range eventually is going to erode away. So the recharging of the phosphorus cycle can take a very long time. Now, how do humans get involved in this whole process? So like I mentioned earlier, phosphorus is something we care about having in our fertilizer, so we will artificially break down the rocks into these smaller bits to create fertilizer. We utilize high amounts of fertilizer in agriculture, and that fertilizer can run off into water bodies from farming. So we can add excess fertilizer or phosphates into this system at this particular step. Okay, I want you to think about these questions and try to answer them. At any point, did it change states of matter, the phosphorus? Did it go from like a gaseous phase? Did it go into a liquid phase? Did you have bacteria that were converting the phosphorus into more usable forms like you saw in the carbon cycle and the nitrogen cycle? Think about those questions. So some really important facts about the phosphorus cycle. It is pretty much only one state of matter that you see a solid state of matter. The main inorganic reservoir are basically in sediment deposits in mountains or from the ocean floor. So it takes a long time to actually recharge the natural deposits. It can take hundreds of thousands to millions of years. So the scale of the phosphorus cycle, or the cycling of it, is a lot longer compared to the carbon and nitrogen cycle. Okay. Now, excessive phosphates in fertilizer, just like we saw in the nitrogen cycle, they can also cause algal blooms. So again, when you have something that limits plant growth that's added in excess, you're going to have a lot of photosynthetic activity in our waterways, and these algal blooms can release toxic compounds that can harm the air quality of the communities nearby and also remove a lot of nutrients from the water, basically decreasing the water quality and significantly having a negative impact on the communities there. So algal blooms are pretty bad, and the phosphates again can cause similar algal blooms compared to having excess nitrates. The next one we're going to talk about is the water cycle, which is hopefully something you've seen from elementary school or middle school. I'm actually going to put a link for what I think does a much better job of teaching the water cycle, this little song. So please watch that as well. But I'm very briefly just going to go over the water cycle starting at number 1. So you have evaporation, where you have a liquid form of water that is getting heat energy from the sun and sunlight as well, and that causes it to get into a high enough energy state that it becomes gas. And it's warm gas, and it'll rise up, and then as it goes up in the atmosphere, which is much cooler, it's going to cool, and it will condense into clouds, and those clouds can move, and when you have enough water vapor present in those clouds, it's going to rain as precipitation. You can have different types of precipitation, so you can have just regular water droplets, or if it's at a high enough elevation, it's much cooler, you can have snow and ice. Okay, so if we look here as well, you can also have transpiration, which is when living organisms are going to release water vapor that again will condense back up into clouds. So let's look at this case where the cloud is releasing snow. So the snow is going to melt off, and that is going to flow as streams and rivers, process known as surface flow, and it's added into a body of water. Now let's talk about how groundwater moves. So in the bedrock, this is not just solid bedrock, it's porous, meaning you can have little openings for the water to flow out. That water is going to flow into a groundwater deposit, another process known as percolation. And you have groundwater that can also move in between different bodies of water or itself. Plants will also take up water from this groundwater level. So you can see kind of these steps pretty much where you have evaporation, condensation, precipitation, runoff, where it goes back into these bodies of water, and the whole process begins again. So please watch the water cycle song if you want something stuck in your head all day and you don't want to forget these processes.